Everyone, good evening. In our previous session, we discussed about the four colligative properties. The first one is relative lowering of vapor pressure, and the second one is elevation in boiling point. This will be Ts minus T naught I was given. Delta Tb is nothing but it is Ts minus T naught. Ts minus T naught given, and delta Tf was given, that is as T naught minus Ts like that, and here pi is osmotic pressure, I is equals to CRT, and I we use for non-ideal solutions. I is a Van der factor, but for ideal solution there will be only particular concentrations, there won't be I. Okay, so I will be 1 for ideal solutions. For ideal solutions, I is equals to 1 we have to take. Because, see, for dissociation, I is equals to 1 plus alpha into n minus 1. Whereas alpha is degree of dissociation. And for ideal solution, n value is equals to 1. Because there is no association or there is no dissociation. Suppose if you consider 1 mole, so 1 mole only will be present. So n is equals to 1. 1 minus 1, 0. So I is equals to 1 for ideal solutions. I is equals to 1 for ideal solutions. Got it? So I will be 1 everywhere here if it is ideal solution. If the solution is a non-ideal, non-ideal means either undergoing dissociation or association. Non-ideal. For non-ideal solutions, we use I value like this. What we use? I is equals to 1 plus alpha into n minus 1. For dissociation, I is equals to 1 plus alpha into 1 by n minus 1. That is for association. So I will be different for dissociation or association. These two happens for non-ideal solutions. So I value we have here. In that alpha value we have. How to consider alpha? I told you very clearly. If a particular solute is dissociated, suppose X, Y is a solute that was dissociated as X plus and Y minus. So about how much percentage it was dissociated, if they said like 60%, alpha will be 0.6. X plus Y minus 2 ions, so n value will be 2 we have to consider. Okay, so in this we have one clarity. We have no need to consider I, that is I is equals to 1 for ideal solutions. I is having some value for non-ideal solutions. Got it? So finally we discussed here some osmotic pressure. Pi is equals to ICRT. What is pi? Osmotic pressure. What is I? Quantum factor. C, concentration. What is R? Gas constant, we know 0.0821 we have to take here, and T is the temperature. Got it? So here, what are the isotonic solutions? What are the hypertonic solutions? What are hypotonic solutions? Let's see. Okay, you know already, if two solutions having same osmotic pressure, they are called isotonic. Isotonic solutions. Isotonic solutions means the particular solutions which have same osmotic pressure are called isotonic solutions. Got it? So here two solutions having particular osmotic pressures, pi 1 and pi 2, same, both are same. Pi 1 is equal to pi 2. They are isotonic. Two solutions. One solution having some NaOH and another solution is having some other solute like that. Who are isotonic in our general life? Okay, you can say 0.9% weight by volume of NaCl, bright solution we call is isotonic. Isotonic with blood. Okay, so isotonic solutions we have to use for injections. if we are using this 0.9% weight by volume of NaCl is isotonic with the blood. If hypertonic, next, hypertonic solutions. What are hypertonic solutions? The solution, the particular solution which is having more osmotic pressure than other one is called hypertonic. See, greater than 0.9% weight by volume of brine solution or NaCl solution is hypertonic. Hypertonic with blood. This is one. And third one is hypotonic solution. Same, but the solution which have less osmotic pressure than other is called hypotonic solution. Generally, hypotonic solution example same only, less than 0.9%, less than, particular solutions are less than 0.9% weight by volume of NaCl. Less than 0.9%. If it is there, that particular is called hypotonic solution. Three kinds of solutions we have: isotonic solution, hypertonic solution, and hypotonic. Very important for us. They'll ask you in numericals if two solutions are isotonic one to other, then what is the particular molar mass of one? Like that they will ask you question by giving some information of other. Got it? So these are very important. I was given some information about osmotic pressure. There are three types of solutions. One are isotonic solution and hypertonic solution, hypotonic solution based on osmotic pressures. If two solutions having same osmotic pressure, they are called isotonic solutions. Got it? Next, we have to discuss about some applications to calculate colligative properties. Let's see some properties. What is the delta TV formula? Delta TV is equals to Ts minus T0 is equals to I into Kf into molarity. This is formula, right? But okay. Next, I will write here pi is equals to ICRT. So they'll ask you questions like this. I we are using means we are considering non-ideal solutions. Got it? Okay. So they'll ask you by giving four options which solution has more elevation in boiling point, or else which solution has more boiling point, means Ts which has more, they'll ask you. Got it? Suppose I will consider for same concentration 0.1 m NaCl, 0.1 m urea, 0.1 m some magnesium chloride MgCl2, 0.1 m some Na2SO4 like this. Na2SO4 is 3 ions. Okay, I'll give you another example like Al2SO4 thrice. Like this, I'm taking different solutions. Here NaCl solution and urea solution. Suppose here delta TB is, I'm going to write delta TB. Delta TB is equals to what? Ts minus T0 is equals to, these are all suppose 100% dissociated. 100% dissociated means alpha will be what? 1. Okay, so here you can take 100% dissociate, number of ions you can take as I. This is a very important note for you. Okay, if the solution there was not mentioned 60% dissociated, 70% dissociated, like that not mentioned, means they are strong electrolytes, they dissociate 100%. Here I was not mentioned alpha, how much dissociated I was not mentioned, so 100% dissociated. So NaCl dissociated into Na plus and Cl minus. So I value I have to consider 2 here. So Kf into the concentration is 0.1. Got it? So here delta Tb is equals to nothing. Urea is the ideal. No dissociation, no association. Simply 1 into Kf into 0.1 here. Okay. Here delta Tb. Delta Tb is equals to how many ions? Mg2 plus 2Cl minus 3 ions. 3 into Kf into 0.1. And here delta Tb is equals to 2 ions and here 3 ions, total 5. So 5 into Kf into 0.1. So why I am giving these examples? These are the 4 options. Suppose this is the first option and this is second option and this is third and this is fourth option. Which of the following has more elevation in boiling point, or which of the following solution has more boiling point, like that if they ask? From this information you can say, or you can say number of ions increased. They said 100%. Getting what I am saying? So here 5 ions. So 5 into this, here 3 into this, here 1 into this, here 2 into this. So which has more elevation in boiling point is fourth option. Which has more boiling point means Ts minus T naught. More means Ts, delta Tb is more means Ts is more. Because here T naught we are subtracting. More the number of ions are increased, more will be the non-volatile particles. So Tb, delta Tb value will be more. Delta Tb value is more means nothing but what? This will be more. Ts is more. Because non-volatile particles are more. Got it? So here very clear what number of particles increases. Number of particles increases, that delta Tb value increases and Ts value also increases. This is a very important thing for you. Number of particles increases, so that delta Tb increases, Ts increases. I was written just for understanding. If you don't know this one, just look at these salts. Here 5 ions are there, here 3 ions are there, here no dissociation, here 2 ions are there. Okay, number of ions are more, so particles are more. This has more delta Tb as well as Ts. That you have to say. Same story for these you can say, if 100% dissociated, alpha is very important. 100% dissociated means I is equals to number of particles. Got it? So I will ask you one question here. Suppose 0.1 m K4FeCN 6 times. 0.1 m some HX, some weak acid. Now my question, among these two, which has more osmotic pressure? This has osmotic pressure is pi 1 and this has osmotic pressure pi 2. It's very clear. In the same way you can write here pi is equals to 100% dissociated. Here also I am considering. They will give you 100%, 60%, 70%, like that they will give you. Don't worry. If they was not given, then 100% dissociated. Then I is equals to number of particles. It's very clear. Note it down. Okay? 100% dissociated means I is equals to number of ions. How many ions? 4K plus, and this is 1. This is complex sphere, it won't dissociate. So total 5 into CRT. Concentration is 0.1. So 5 into 0.1 into RT. Here for the second example, this is example 1 and this is example 2. For the second example, pi is equals to 2 into 0.1 into RT. Why sir? Because H plus X minus, it will dissociate as H plus X minus, 2 ions. So 2 into 0.1 into RT. So which is big? Certainly you can say among these example 1 and example 2, this is pi 1 and this is pi 2. Pi 1 is greater than pi 2. Very clear. Here also same story. If the number of particles increases, osmotic pressure increases. So I value increases, these values will increase. That is also very clear. So I can conclude that number of particles increases for a particular concentration. If alpha is particular, same dissociation I am telling, alpha is 100% I am considering. Number of particles increases, I value increases, delta TB increases, TS increases, pi value also increases. This is the important note for you. Number of particles increases, I value increases, delta TB increases if you have this. These all are directly proportional. But it very useful, very much useful for our numericals. Okay, to solve different numericals. Very important. Once again, I am repeating: number of particles increases, then I value increases, then delta TB increases, then TS value increases, then pi value increases. But when depends on concentrations. Okay, I am considering same concentration here. I am considering 100% dissociation. These two are very important. Sir, different concentrations given, sir. Sir, different I value given, sir. Alpha given, different dissociation given, sir. Then you have to substitute and you have to calculate the value. Here I value you have to calculate, and here you have to calculate molarity and you have to multiply. Then you have to see which is big. But generally I am telling, last and final, don't get confused. If 100% given, same concentrations given, got it? Then I was given one important relation. Here only I can say, if number of particles increases, then number of particles increases, then delta TB increases, TS increases, pi value also increases. This is the final conclusion for you. Final conclusion. Got it? Okay. Now for depression and freezing point also we have to see once. Okay, what will happen for depression and freezing point? So everything I will give you as a summary afterwards. So first you must know all these things. Okay, write it down everybody. This is a very important concept for you. But why important means you are going to write the competitive exams. So these are very important. So next, delta TF is equal to T naught minus Ts is equal to I into Kf into M. So here you have I, Kf and M, but T naught minus Ts here. So for the same I will take some examples. Suppose 0.1 M some acetone, CH3, C double bond O, CH3, there is no association or dissociation, and 0.1 M some NaCl, and 0.1 M MgCl2. 3 examples enough. Okay, so here also I am considering NaCl and MgCl2. As we know, these are highly ionic, so 100% they will dissociate. So I value will be number of ions for this. So for here delta TF is equals to T naught minus Ts is equals to how many ions? Only one. It won't undergo any dissociation, so only one. So 1 into Kf, how much concentration? 0.1. So Kf into 0.1, 1 into. So here for this, delta TF is equals to T naught minus Ts. Solution freezing point. This is S means solution freezing point. You know already. This is the freezing point of pure solvent. Got it? And here it is 2 into Kf into 0.1. Sir, why sir? Delta TF, I told you very clearly, solution freezing point is less. That's why we call it depression. Depression means decreased. Got it? So NaCl, why you consider 2 means Na plus and Cl minus. MgCl2 means Mg2 plus 2Cl minus. That means number of ions 1 Mg and 2 chlorines. Okay. So delta Tf is equals to, and here T naught minus Ts is equals to 3 into Kf into 0.1. Now my question, among these three, in aqueous medium, aqueous medium means, remember everybody, freezing point of water, freezing point of water is 0 degrees Celsius. Freezing point of water, H2. They won't give in numericals, sir. Aqueous solution, they said, means this will be T naught. That's it. 0 degrees Celsius we have to consider for aqueous solutions for solving numericals. Sir, boiling point of water, everybody knows 100 degrees Celsius we have to consider. That also they won't provide in numericals. Got it? Aqueous medium, they said, means freezing point of water is 0 degrees. Freezing point of water means solvent, that I am considering as T naught. So T naught is equals to 0 degrees Celsius. So in all these three I can write I can write 0 minus Ts is equals to Kf into 0.1. This one, 0 minus Ts is equals to 2 into Kf. If you confuse all three at one place, I'll write here. The first one, 0 minus Ts is equals to Kf into 0.1. That implies Ts is equals to minus Kf into 0.1. Okay, here, second one, 0 minus Ts is equals to 2 into Kf into 0.1. That implies Ts is equals to minus 2 into Kf into that same 0.1. Kf minus 2 into Kf into 0.1. Here, third one, delta Tf is equals to T naught minus Ts. T naught is 0 degrees for aqueous. Aqueous means water. For water, freezing point is 0. I am repeating because you must be very much careful about this. 0 minus Ts is equals to, for third one, 3 into Kf into 0.1. That implies Ts is equals to minus 3 into Kf into 0.1. That's it. Got it? So observe these three, you only will say, if number of particles increases, what happens? If number of particles increases, then what happens? Ts value will decrease. Ts value will, see, number of particles is 3. So 3 into something, this will be more, this will be less. So then what you can say, if number of particles increases, I value increases and Ts value decreases. Ts value decreases. Of course, delta Tf will increase because delta Tf is equals to T naught minus Ts. Ts value is less. So that T naught value will increase. So something what you are subtracting is less. So delta Tf value increases. This is very clear, last and final. So what I said, just don't get confused. Just listen carefully. If number of particles increases, then I value increases, no doubt. But Ts, where Ts means, don't get confused. Here I am talking about a freezing point. There Ts, I told you, that is boiling point. Got it? They will say boiling point or freezing point. They will mention in numericals. We have no need to worry. Got it? Otherwise, you write out Tf, not a problem. Freezing point. Tb, you write out boiling point. Got it? So Ts value decreases, that is freezing point of solution decreases. But just have a look, once last and final I repeat, if number of particles increases, I value increases, but freezing point of solution decreases. This is the proof for you. MgCl2, you have more number of ions, but here you have -3 into Kf is your water. So here I am considering for same kind of medium, that is also very important. If the different given means, you have to substitute those and you have to decide by calculating. But all at one place I will write now. Okay? How they change. Okay, one by one you can see. Last and final. So here it is very clear. If you must focus here, if number of particles increases, this is the condition. Then one by one. Okay, number one. If number of particles increases, then I value increases. Okay, then delta TB value increases, then TB value also increases, whereas TB is equals to boiling point of solution. This is very clear. So this is the final summary what we have in previous. If number of particles increases, then number of particles increases, then I value increases, delta TB increases, as well as boiling point of solution also increases. If same, and you can write second, I value increases, therefore osmotic pressure also increases, second one. Got it? And third one, if number of particles increases, third one, I value increases, fine. But delta TF I tell you, but TF I tell you first. TF value decreases, delta TF value increases. Don't get confused. These three are very important, and take a screenshot and just place in your phone. Carefully. Okay. If number of particles increases, I value increases, delta TB value increases, TB value increases. And I am not saying blindly you have to remember all this. I was given a proof already. For a particular medium I am talking. Okay, medium also important. And this is for water medium, like it's very important. Okay. So all four examples should be for same medium, and this will be directly you can answer. Okay. If different mediums given means individually you have to calculate by using formula, which is having like that. They won't ask because 4 options means 4 times you have to solve numerics. Mostly they will give one kind of medium method. Got it? Okay. So these are very important. Got it? Same sir, if even asking RLDP also. RLDP is equals to I into mole fraction of solute. So I increases, relative lowering of vapor pressure also increases. So I is directly proportional for everything, but only thing this will decrease. Freezing point of solution decrease, where TF is a freezing point of solution. That's it. But